Next, we will discuss software wrapping in the context of software migration, legacy systems, and re-engineering. The concept of wrapping was introduced in IBM at 1988. The idea is to encapsulate the legacy component with new software layer. So the legacy component is hidden behind this wrapper. This wrapper completely covers it, and there is no way to see the legacy component anymore. So you have this wrapper interface around your legacy component. Some common ways to do this wrapping would be sockets, REST API, RPC, which is a remote procedure call, or some programming language specific API. So you might have Java API, Python API, C API, or you might have them all for a particular legacy component if this legacy component is very important. In this context, we see the legacy software as a server, and it provides some black box services. So we don't know what happens in the background. We just know that those are sort of unmutable, those services, because the legacy component is not easily modified. The concept of wrapping is also applicable to non-legacy components. So if we think of modern web service-based system, it typically works like this. So we have mobile phone apps and we have web pages that are used to access the web services via the REST API. And what happens behind the REST API is a complete black box. I mean, who knows? This might be a legacy component from 1980s running in the background, or it might be some modern stuff. But regardless, we don't know what happens behind this REST API. So we have a complete black box here, and we can basically run anything we like in the background. In essence, the wrapper is a software layer that transmits queries from client to server. This server, the legacy component or system we need to deal with, while the client can be anything from a single component to a whole system or even hundreds of users. The wrapper takes a set of inputs from the client, transforms the input in a way that can be understood by the legacy component, and then forwards the query to the legacy component. Then, when it receives the reply from the legacy component, it transforms the output so it can be understood and forwards it back to the client. So while wrapper allows to communicate with the legacy component or system in a different and a potentially better way, it doesn't solve any maintainability problem related to the legacy system. Indeed, the wrapper only allows to modify the interface of the system, but extending or modifying the existing functionality of the legacy system is still as hard as it was before. There can be different types of wrappers. We can have a database wrapper that basically encapsulates the old database and allows access to this legacy database system. We can have wrappers around system services. So if we have a printing functionality that is a system service, we can wrap it around to a modern interface. We can have different applications. For example, how to update customer information could be provided in a wrapper from the legacy system. And then even at the very lowest level, we can have a function wrappers. For example, assume that you have spent a lot of time in programming a zip code control or email code control, or something that basically just controls an input in a particular field of an application. So it checks, for example, that the zip code is valid, and you have made many different things to it so that it functions correctly, and this is part of the legacy system. So you might want to wrap around that so that you can still use the excellent zip code control in a new system you are migrating to. So you just wrap around the different things you need in the new system. Here we can see more details about the database wrapper. On the left side, we have the forward wrapper. This would be used if you have a legacy application, but you would like to introduce some new application as part of the legacy application. So what do we have in the figure? So we have the legacy application on the far left. Then on the middle we have the legacy database management system, and then we have the legacy data. So these are the white boxes. So let's say you want to introduce a new application, let's say a new web application with some new programming language. So then you need to do a forward wrapper that wraps the database management system and interacts with the database management system and the new applications. And little by little you would bring on these new applications and they would work with the forward wrapper. But maybe at some point you got tired of the legacy database management system and you want to get rid of it. So now if you move from the forward wrapper to the backward wrapper case, you can ditch the forward wrapper, as the new application would directly work with the new database management system and the new data. So here on the right, we have a new application, new database management system, and new data. But you still have some legacy applications on part of that. So then you need a backward wrapper from the legacy application, and then you have a wrapper to the new database system. So this is a backward wrapper from the backwards, allowing backward access to the legacy system and the new system. Also, screen scraping can be used to build a wrapper. So let's assume that we still have the legacy data, legacy database management system, and legacy application. And we have a plan for this new application and this forward wrapper in this level. So we would re-implement the application here. But let's say a manager comes along and decides, well, this is too expensive. I want something faster and cheaper. So then another option would be to lose the wrapper and the new application and simply do screen scraping. So we use the legacy application directly from the interface. We have a screen scraper that basically translates the information in the old screen to the new screen. And obviously this also works backwards from the user interface to the screen scraper and then pushes it to the legacy application. And this would be a way, let's say you have a legacy Windows native application that only runs inside a Windows machine, some executable, and you want to do it the modern web interface on top of it, but you don't have a lot of time. So then you could just consider using a screen scraper on top of that and then provide the web access through the screen scraper. And this would be a simple way to do this. There are commercial tools that can help you. So now you have a simple way of using the legacy system through a new user interface. And like with other wrapping solution, this is a short-term solution. It doesn't have any possibility to evolve functionality, and it probably has a high maintenance costs as well. But this is something that can get you started quite quickly. So as you can see, wrappers can be of different types. Screen scrape wrapper, we can have a database wrapper, and then we can have function wrappers, we can have application wrappers and server wrappers.